Hello everyone, welcome back to the channel Streak to Skill. So this is the part 3 for high-level design of a rate limiter. Okay, in the last video we have discussed some algorithms for rate limiting and a basic high-level design. In this video we will see how distributed concepts come into picture for our design and how we will satisfy the non-functional requirements for the design we have made. Okay, in our design, we were just using one instance of the API gateway, which was handling all the rate limiting, right? But we in our non-functional requirements, we have discussed that we have 1 million requests per second, and only one instance can't handle it. So we need to have multiple instances. Okay, and the instance was doing operations on Redis, like reading and then updating, right? But what if the same user hits both the API gateways at the same time, and then both will reach to Redis and do this operations, right? And this is a common memory, and two threads are updating it simultaneously. This will create a race condition, right? So to solve this race condition, what we can do first is we can use a locking kind of mechanism. But we have also discussed that we need low latency, and if we use locking kind of mechanism, it will increase the latency. So the solution for this is what Redis only provides us. It provides us Lua script and sorted sets data structure. So you guys can read more about this. But in the interview, just tell that uh, there will be a race condition. We will for this much scale, we'll need to add multiple instances of the API gateway. Okay, now we have discussed that we will require multiple gateways, right? But still we are using the same Redis instance and we are handling 1 million requests per second. Now this Redis instance on an average can do 100k operations. Okay, but we have 1 million requests per second, right? And we are at a particular moment doing two operations, getting and setting, right? So it boils down to 50k on average. So if we do calculations for for handling this much amount of data will require 20 instances of the Redis. So we can do the sharding of data, right? We will require 20 shards. So how to shard the data? So we can shard on the basis of the user IP or on the user ID and then apply consistent hashing. But when you are using Redis, we can just use a Redis cluster. It uses hash slots to do all the working of the consistent hashing. You don't need to apply the consistent hashing logic when you are using a Redis cluster. The main thing that you need to tell in an interview is that when you are handling such a large amount of data, you will just need to shard the data. Okay, the next functional requirement we discussed was that the system must be available. Now we have discussed we can use multiple API gateways. But suppose in the Redis cluster, if in a particular node dies, right, then our data might be lost. So what we can do is we need to apply the replicas for it. The data should be replicated in some other node too. We can define a replication factor in the Redis cluster, which will replica the data accordingly. Okay, the next function requirement we discussed was low latency. Now what's happening in our system is the user will request and the API gateway will do a network call to the Redis cluster. But this will increase our latency, right? We don't want this to happen again and again. So what we can do is we can use consistent pool of connection. Okay, so we can use just connection pool and use the same TCP connection again and again. So we don't need to go to the Redis cluster again and again. Okay, if you have users in various geographical locations, uh, try to keep your instances as close to the continent as possible to reduce the latency. One more thing the interviewer can ask is, currently you have static rules defined on the API gateway, right? What if the rules changes? So how to handle this? The first option can be the rules are present on the database and our gateway is polling them again and again. Okay, this will be a bad option because uh, this will add to the latency. Like we are just polling things. The second is don't poll from the database. Just put your rules in the Redis and then again poll. Okay, so this will be better latency than the first, but still not good solution. The best solution is, okay, the best solution is using the push mechanism. So we can store the rules on the zookeeper. Whenever the API gateway is on, it will register itself on the zookeeper, and it will also watch for the changes of the rules. Okay, and whenever there is a change in the rule, all the gateway will be notified about it from the zookeeper only. Good job, guys. You have completed the high level design of a rate limiting system. Let's meet again soon with another high level design. Thank you. Okay, that's it for this problem. Thanks for watching. If you want more content on LLD, HLD, Gen AI, DSA, and software engineering projects, do consider subscribing us. Thank you.